So for the day 3 notes for chapter 11, we are going to talk about ellipses. So the definition of an ellipse is up here. It's the set of all points in a plane whose distances from two fixed points, called foci, in a plane have a constant sum. And what I like to do is take what sounds like a very mathematical definition and try and at least give you a visual as to what that definition means. So I'm going to draw a picture for it. So if I draw an ellipse here, it doesn't matter if I draw it wider from left to right or wider from top to bottom, the same idea will hold. So what it says is the set of all points whose distances from two fixed points called foci. So in our ellipse analysis video that you hopefully watched before this, or in general, I can explain it here, but the foci of the ellipse will always be points somewhere between the center and the vertices or edges of my ellipse. So in blue here I plotted two foci. So what this definition is saying is if I were to pick a point on the ellipse, so any point, so let's say I picked a point here, and I draw a line that connects that point to each focus, if I were to take the distances of those two lines and add them together, I would get obviously a number, a sum. And what makes this ellipse shape is if I picked any other point on the ellipse. So let's say I picked this point right there, drew it in blue. If I were to connect that point to each focus, the distances I get added together there should be the same as the distances I got for the other point and for any point on this ellipse. So the idea is any point I have on the ellipse should be the sum of the distances from that point to the two foci will always be the same. So what happens there is that's essentially what creates this oval shape, because depending on where the foci are and where the center is in terms of that distance, if I draw some distances from the foci to some point on the ellipse, the sum of those distances will always be the same. And that's, again, what creates this oval shape. You're not going to specifically be asked to define an ellipse or explain where this comes from, but I do like to try and give a visual as to why ellipses look the way they look. And if you go on YouTube and type in ellipse construction with a string, it'll kind of walk through a video demonstration of what's happening there, which is pretty cool if you have the time or the curiosity to look it up. So in terms of our standard equations for ellipses, we looked at a couple examples already, but in general, the couple things I want you to notice is we have x minus h quantity squared and y minus k quantity squared. Should look very familiar in terms of our parabola stuff. The only difference here is both variables are being squared. They're being added together and set equal to 1. So that's what identifies specifically an ellipse, and that's again for the vertex at hk something other than 0, 0. If the vertex was at 0, 0, it would just be x squared over a squared plus y squared over b squared equals 1, or vice versa. Now the reason why we write these as two separate equations, although adding two things together, it doesn't matter what order I write them, is because a, if you notice, a squared was underneath x in the first equation and a squared is underneath y in the second equation. A will always be the larger of the two denominators, always. So a squared will always be greater than b squared because a will always be greater than b. So what we'll have to look at is, depending on which variable has the larger denominator, that's going to be our a value. And you'll see how that works out here in the first example. So for the first example here, we are given an equation of an ellipse and we're asked to identify the center, vertices, and foci and sketch the graph. So the first thing I like to do is identify the center. So I look at the equation and see that it's just x squared and y squared. Nothing is being added or subtracted to x or y. So I can say the center is going to be 0, 0. And then, in terms of what the vertices are the endpoints of the ellipse in whatever direction the ellipse is wider. And what I mean by that is if you look at this equation, we have 9 underneath x squared and we have 4 underneath y squared. So what that tells me is my a value, or my a squared value, is going to be 9, because remember, a squared will always be the larger one. So in this case, a is 3. And then b squared is going to be 4, which means b is 2. So what that means for my graph is if I graph my center, and then my a value will be the number of units or the amount of space or distance I go left or right of center, because in this case a is underneath my x variable. So I'm going to go left and right 3, and then I'm going to go up and down from center 2, and that's my b value. So I can sketch my ellipse here. The only thing I need to do then is identify the vertices, and then I will have to find and plot the foci or foci of this ellipse. So where are the vertices? Again, the vertices are the endpoints of the ellipse in whatever direction the ellipse is wider in. So this ellipse specifically, is wider horizontally or in the x direction or left to right. All of those are synonyms to me. So what I need to do is identify the coordinates of the points at the end. So in this case, because a was 3, I'm going to go left and right 3 of 0, 0, which puts me at -3, 0, and +3, 0. Those are the two vertices of this ellipse. Now, in terms of finding the foci, we talked about what the foci are, and they are fixed points somewhere between the vertex and the center on either side. So there's an equation that helps us find our c value, which again, the c value is the distance from the center to the foci, and the equation is this: a squared equals b squared plus c squared. So that looks a lot like the Pythagorean theorem. The difference here, though, is a squared is equal to b squared plus c squared, rather than c squared being equal to a squared plus b squared. And here's how I keep that straight. Remember, a is the distance from the center to the vertex. So in this case, a would be 3. And I need a to be larger than c. And again, that has to happen because my focus is somewhere between the vertex and the center. So my c value has to be less than my a value. So the way I think about that is a is equal to c squared plus b squared, which means c should automatically be less than a. So here's how that works out. Again, a squared in this case is 9. So I get 9 equals, and b squared is 4. So I can call this 9 equals 4 plus c squared. Solve for c, I should get the square root of 5. Now I don't need you to know the exact decimal value of the square root of 5. I'm going to leave my coordinates in terms of the radical, but in terms of plotting, you should have an idea of about what the square root of 5 is. And the square root of 5 is slightly more than 2. It's like 2.2-ish, somewhere around there. So it's slightly more than 2, and the reason I know that is the square root of 4 is 2, the square root of 9 is 3, so the square root of 5 has got to be somewhere between 2 and 3. So how do I plot that? So I'm going to go on my graph and plot a point somewhere between 2 and 3 units away from the center, almost out to my vertices. Not quite, because square root of 5 is less than 3, but somewhere around there. So that's how I'd graph them. Again, I'm not going to have you be ultra specific because we don't have a calculator right now, so we can't say exactly what the decimal is. It's going to be somewhere between 2 and 3. So if I plot my foci, I just need to say the coordinates of them, and the coordinates in this case would be -√5, 0, and +√5, 0. So I need the equation a squared equals b squared plus c squared to find my c value, and then I need my c value to know where to put my two foci for this ellipse. So let's take a look at another example here. So example 2, we want to sketch the graph and identify the same information. So I look at my equation here. I have x squared over 13 plus y squared over 75 is 1. So the major difference here is the numbers in the denominator of my variables are not perfect squares. And that happens at times. They don't have to be perfect squares at all. 13 and 75 are definitely viable numbers in terms of creating the shape of an ellipse. So we'll walk through this process on how to deal with these numbers when they're not perfect squares. So the first thing we should be able to say for sure is the center is still 0, 0, because x and y are not being shifted left or right or up or down, so I can say my center is 0, 0. And then here's how we have to find our vertices. I'm going to sketch the graph and then identify the vertices from there. So what I have to do is pick what a squared is going to be, and again, a squared will always be the larger of the two denominators. So in this case, a squared is going to be 75, and b squared is going to be 13. So that means a is the square root of 75, and b should be the square root of 13. Now again, those are not perfect squares, I would leave them just like this because it's a little bit easier, in my opinion, to have an approximation for the radical when it's the square root of 75 versus 5 root 3. Like, I don't know what 5 root 3 is off the top of my head, but I could say that the square root of 75 should be somewhere between 8 and 9. The reason I know that is 8 squared is 64, 9 squared is 81, so 75 is somewhere between 64 and 81, which means A should be somewhere between 8 and 9. So how do I graph that? Again, A is the larger of the two denominators, or the square root of the larger of the two denominators. And because the larger denominator is underneath my y variable, I need to go the square root of 75 units above and below my center, because it's in the y direction. So square root of 75, like I said, is 8 point something. So I'm going to plot a point somewhere between 8 and 9. You put it right at halfway. Again, you could put it somewhere between 8 and 9 is really as specific as I'll ask you to get. And then how about in the x direction? So because 13 is underneath x, the square root of 13 is something close to 4. It's 3 point something. Because 3 squared is 9 and 4 squared is 16. 13 is really close to 16, so it's going to be probably like 3.8-ish, somewhere around there. And again, I don't care that you find the decimal or not. If you can tell me where the square root of 13 is, then we can plot that. So I'm going to plot those 2 points somewhere between 3 and 4, and then I'm going to sketch my ellipse. So it should look something like that. So where are the vertices? So again, the vertices would be the endpoints of the ellipse in whatever direction the ellipse is wider in, which in this case is vertically from top to bottom. So my vertices are actually going to be just the A value above and below the vertex. So in this case it would be the 0 square root of 75 and 0 negative square root of 75. Those are my two vertices. I'd rather you give me the radical than the decimal, especially if you don't have access to a calculator. So there are my vertices. And then where are my foci? I need to find C before I can say exactly where those foci are. So the way I do that is by using the equation a squared equals b squared plus c squared. And then I replace a squared and b squared with my a squared and b squared values, which I identified at the very beginning of the problem, which are 75 and 13. So if I solve for c, I would get c to be the square root of 62. And now where is the square root of 62? It's somewhere between 7 and 8. It's actually really close to 8. So how do I graph it? Again, the foci should be in the same direction as the vertices, and in this case it would be above and below the center. So I'm going to go up just under 8 units in each direction vertically and plot my foci there. And then what the coordinates of those foci should be are 0 root 62 and 0 negative root 62. So in this example, neither A nor B nor C worked out to be nice integer numbers, which is still fine. I just have to have an idea as to where those values are when I plot the graph and try and be as careful and specific as I possibly can. For the last example today, we're going to look at, we have an equation for an ellipse, but it is not in standard form. Here's a quick way to recognize that it's an ellipse. X and y are both squared, and there's an addition sign between them, but this equation is not x squared over a number plus y squared over a number equals 1. So I'm going to make it that way. So what I would do is, I'm just going to write my equation over here. Here's how you would rewrite this equation, or what you would do to it to get it to be in what we call standard form. I need the right side to be equal to 1. So what I would do is, actually, if I divided that right side by 64, I would get 1, because 64 over 64 is 1. But in an equation, whatever I do to one side, I need to do to the other. So I'm actually going to divide everything by 64. So what I should get when I do that is 16x squared over 64 becomes 1x squared over 4, or just x squared over 4, plus y squared over 16 equals 1. And now this is the standard form equation for an ellipse that has a center of 0, 0. So the center is 0, 0, and then I need to figure out how to plot this ellipse and how many units from the center I have to go in each direction. So again, a squared will always be the larger of the two denominators. So in this case, a squared is going to be 16, and b squared is going to be 4. So that means a is going to be 4, and b is going to be 2. So because the 16 the larger of the two denominators was underneath my y variable, I need to go 4 units above and below the center. And those points are actually going to be my vertices, because that's the direction the parabola is wider in. And I'll write the coordinates there here in a second. And then I should go 2 units to the right and left, and I should have my ellipse here. So in terms of identifying the last two pieces of information, I already said the vertices should be at the points 0, 4, and 0, -4. And then in terms of finding the foci, I need to remember this equation. A squared equals b squared plus c squared. So replace a squared with 16, replace b squared with 4. So what I should get for c is the square root of 12. And again, having an idea of what that number is as a decimal is very helpful. The square root of 12 is about 3 point something, because 3 squared is 9, 4 squared is 16, so 12 is somewhere between 9 and 16, which means the square root of 12 should be somewhere between 3 and 4. So in terms of plotting it, I'm going to go up 3 point something units and plot a point, call it put a little f for foci, and go 3 point something units down, and those are my foci. So all I need to do is actually write the coordinates, which in this case I'm going to leave in radicals: 0, square root of 12, and 0, negative square root of 12. So for day 3, we primarily focused on identifying and sketching from an equation. Know that every ellipse has a center, 2 vertices, and 2 foci, every single one. Where they are will depend on the equation for sure. And this last example here is one where we have to do a little bit of work to get the equation in standard form before I try and, identify A and B and C. You first want to get your graph in standard form.